any short-form social feed today, you will immediately encounter a highly specific format: an anonymous narrator reading a sensational Reddit story over a split screen of kinetic gameplay in a voxel environment. We instinctively attribute these videos to a human sitting behind a desk, downloading footage and recording a microphone. That assumption is incorrect. These videos are the compiled output of code. What you are actually looking at is a machine designed for algorithmic arbitrage. It is the process of trading cheap, automated computing power to capture highly predictable human attention. That captured attention translates directly to revenue. Platforms like TikTok and YouTube distribute creator fund payouts based strictly on retained watch time. If an account can hold viewers for 30 seconds, the platform pays out cold cash. To maximize that cash flow, operators remove human labor entirely. From selecting a viral topic to rendering the final MP4 and pushing it live, the entire content factory runs completely headless. Building this operation requires a precise technical stack that splits into 5 distinct layers: data ingestion, text processing, audio synthesis, video assembly, and API distribution. The data travels sequentially through these layers. Each tier executes programmatic logic and passes assets to the next stage. We are going to reverse engineer this exact technical architecture to see exactly how it sources data, bypasses API limitations, and evades platform detection algorithms. Deconstructing this automated machine reveals the underlying infrastructure of the modern attention economy. The first engineering challenge is sourcing high-engagement text at scale without human curation. The machine needs raw material, and it needs a lot of it. Standard scraping architectures typically rely on official wrappers, like Python's praw. Those fail almost immediately in this context due to strict rate limits of 100 requests per minute and mandatory OAuth authorization hurdles. To bypass authentication and extract data frictionlessly, developers target Reddit's public JSON endpoints. By simply appending .json to a URL, the automation script pulls the massive raw data payload directly from the backend server. That payload is programmatically filtered for upvote velocity. The script discards low-performing text and pushes the proven high-engagement stories into a structured database. The database hands those raw strings over to an LLM orchestrator, typically running through models like Grok or Gemini for text pre-processing. The prompt instructs the LLM to rewrite the text for audio pacing and segment the script into 3 structural pieces: a hook, a body, and a cliffhanger. This segmentation allows the script to assign these scenes as parallel rendering tasks, drastically reducing compute time. Because this ingestion layer is entirely headless, the factory never runs out of highly optimized raw material. The pipeline now moves to the audio layer. The quality of the synthesized voice directly dictates viewer retention and scroll rates. Premium cloud APIs, like 11 Labs, produce the gold standard for audio, generating emotional, human-like voiceovers that hold attention. This chart shows the unit economics of premium text-to-speech APIs. Paying up to $100 per million characters destroys profit margins. So developers pivot to locally hosted TTS models like Kokoro, driving the unit cost down to a fraction of a cent. The script requires specific outputs. It generates the audio file and returns exact word-level timestamps to perfectly sync the visuals. Ruthlessly managing these TTS unit economics is the difference between a scalable arbitrage system and a money-losing hobby. In the visual assembly phase, the processed text and timestamped audio meet the background footage. This relies on stimuli pairing. Layering high-movement gameplay beneath the story keeps the visual cortex engaged, preventing viewer drop-off. This assembly process is governed by a strict technical filter: YouTube and TikTok's automated reused content detection algorithms. Layering raw gameplay with basic TTS instantly triggers these filters. The platform flags the visual signatures and demonetizes the channel. To survive, engineers force the FFmpeg rendering engine to inject transformative visual signatures. Individual subtitle blocks scale up and down rapidly in perfect sync with the audio. Additionally, background audio ducks dynamically beneath the narration, and slight pixel variations trick the hash checks. The rendering engine operates as an active evasion system built specifically to bypass algorithmic demonetization. With the MP4 successfully rendered, the pipeline reaches its final stage: automated distribution to social platforms. Here, the script hits a major bottleneck. The TikTok content posting API is exceptionally restrictive. Developers face dual restrictions: The API hard caps uploads at 6 requests per minute and requires a mandatory manual application audit. Failing that audit automatically flags the automated posts, locking them into a private visibility state with 0 views. Engineers successfully route around this bottleneck using 2 main methods. They either pay a premium for pre-audited third-party SaaS wrappers, or they push the final videos to a private Telegram bot. The Telegram bot acts as human-in-the-loop failsafe. The server pings the operator's phone with the finished MP4 and the copied metadata, allowing them to manually bypass the API audit with a single tap. Solving these strict distribution limits allows the operator to step completely away, achieving a truly scalable, entirely hands-free content factory that runs 24/7. Stepping back, we can observe the entire constructed pipeline operating as a single, unified machine. On the front end, headless JSON scraping feeds directly into LLM scene segmentation. On the back end, local TTS generation pipes directly into programmatic FFmpeg rendering, heavily packed with evasion tactics. The finalized output navigates the API limits and is pushed through distribution nodes to the platforms. Developers rarely run just one of these pipelines. They deploy dozens in parallel, targeting different niches across multiple accounts simultaneously. The barrier to entry for content creation has structurally shifted. Success in this format requires systems engineering, not creative video editing. As open-source AI models become cheaper and faster to run locally, the volume and sophistication of this programmatic content will scale exponentially. Traditional human creators are now competing directly against optimized, non-sleeping data pipelines for the exact same audience attention. A well-architected automation script is now the defining asset of the modern creator economy.